Hey everyone. So welcome back to grade 10 academic math, and we're going to be talking about linear systems today. So what is a linear system? A linear system is basically a whole set of equations, a bunch of them. It can be, 2, 5, 8, however many you want. It's basically multiple linear relationships. And when we say linear, it means that none of the variables are squared, none of the variables are, square rooted or any sort of strange thing like that. They're just by themselves. The only thing that we're doing to them is multiplying by them by some coefficient, some number. And we can represent them either with equations or we can represent them with lines. And everything we're going to do here in grade 10 is just going to be two equations. So for example, here we have 3x plus 2y equals 1. That's one linear equation. Excuse me. We could rearrange that to, what would that be? That would be negative 3 halves. So y equals negative 3 over 2x plus 1. So it could be, if we solve for y, we could end up with y equals negative 3 over 2x plus 1, y equals mx plus b type form, right? So that's a line, right? And we have a second one. And what we're going to try to do is basically determine where those two lines intersect. So from a graphical point of view, find out a number, or sorry, a pair of numbers, a number for x and a number for y, that satisfies both of those equations. So for example, these two equations here, there's going to be some number x and y. We can write it as an ordered pair. And that number, when I plug it into both those equations, makes the equations true. That's what the word satisfies means. And we're gonna talk about that a little bit more. But let's just go to a graphical view of this. Okay, so let's go to Desmos. Hopefully you guys have seen Desmos already. But let's use Desmos to help us. Oh, my green screen's all wonky at the back there. Oopsies. Oh well, sorry about that. Let's go here. All right. Why don't I just hide my face here for a minute? Yeah. So let's put in an equation. So the equation was 3x, what was it again? Plus 2y equals 1. So there's one equation. So as you can see, this is a line. It goes through positive 1. Oh, sorry, it goes through a half, and there's a slope of, what did we say, negative 3 over 2? Excuse me. And the other equation was x minus 4y equals negative 9. So x minus 4y equals negative 9. And you can see this will make these two lines. And when we say solve this linear system, it basically means determine that number. So the answer here is going to be negative 1, 2. So from our graphical point of view, this number, negative 1, 2, is our solution to the intersection of these two lines. It is the solution to the linear system. The solution is the point of intersection. I might shorten it down to POI. Let's see if that will work again. No, still, sorry. So our solution, we can say xy equals negative 1, 2. Now, how do we check to see if it satisfies this? A way we can do this is we just take our two equations, here for example 3x plus 2y equals 1, and we replace the x and the y with our answer. We replace x with negative 1, we replace y with 2, and we solve. So what do we get? So 3 times negative 1 is negative 3, and 2 times 2 is 4. So 1 equals 1, which is what we want, right? You can say that the left-hand side is equal to the right-hand side. And we can do the same thing for the other equation. X minus 4y equals negative 9. Replacing x with negative 1, replacing y with 2, we end up with negative 1 minus 8, which is negative 9, which is again what we want. The left-hand side is equal to the right-hand side. All right. So this is a graphical way to solve this. Now, what happens if our expressions here, our lines aren't very, this has a nice solution, right? It's had a nice solution here of negative 1 and 2. What if it was slightly different? What if if I change this to 8 or something, right? It'll give me some strange decimal or something like that. We need to find a better method, a more precise method, a more algebraic, we could say, method, and we're going to have two of these. The first one's called substitution. So let's see how we just solve the exact same problem by substitution. So what we would do here is look at the two equations, and we think to ourselves, which of those equations has a variable, x or y, that's easy to isolate? And you can see here that this x is by itself. There's no coefficient. So that one's quite easy to isolate. So let's get it by itself. When I say isolate, I mean by itself. So I'm going to take my equation and I'm going to add 4y to both sides. So I'm going to end up with an expression x equals 4y minus 9. X equals 4y minus 9 tells us what the value of x is with respect to y. So I've taken let's call this equation 1 here, and call this equation 2. So I've taken equation 2 and I've come up with some information from it, a piece of information that x is 4y minus 9. So now we're going to take our first equation, 3x plus 2y equals 1, and we're going to replace the x value in here. We're going to replace x with what we know x is. So I'm going to replace it. So I'm going to put it in brackets, 4y minus 9. So as you can see here, this is the exact same expression. I haven't done anything, but I've just changed how I'm expressing x. Instead of just x, it's 4y minus 9. So now what I can do here is I can multiply 3 times 4y and 3 times negative 9, and I'll come up with 12y minus 27. And as you can see in this equation that I'm looking at right here, there's a y and there's a y. There's no more x's. So I've taken the x information from equation 1 and I've put it into 2 to remove x from the equation. So now I can just solve that. Right? This will be 12y, 2y. I have 12 y's, 2 y's. That's going to be 14 of them. I'm going to bring this over to the other side. It becomes positive 27. So that's going to tell me that 14y is 28. Something multiplied by 14 is 28. So y is just 2. I'm halfway there. I've got most of the answer already. I know that the y value, the value of the answer, the half of the answer is 2. I still need x though, right? So I have an expression right here for x. So let's take that expression, x equals 4y minus 9, replace y with 2, and I end up with negative 1, which is exactly what we wanted. Right? When we had our graph, we knew that the answer was negative 1, 2. And algebraically, we've shown that exact same answer, negative 1, 2. Okay? So this is how we solve by substitution. Now, again, we can check this. We can, remember we checked way back in the other problem here. We showed that we put the numbers back in for x and y, and we got our answer. I'm not going to repeat myself. Okay, so substitution, again, just a quick recap. We take one of the equations, rearrange it, and then we plug it into the other equation. Hi, I'm back. So I take one of my equations here. Let's say this equation number 2 in this case. I took 2 and I solved for x and I replaced it. So that's why it's called substitution. I do this substitution right there. Elimination is the other method. Elimination is, I think, more useful. but it really depends on the situation. But if I look at these two equations, something is quite obvious. If I look at those two equations, I see that there's a 2x and a 2x. Those numbers are exactly the same. Now, I'm going to do something a bit weird. I'm going to subtract the two equations from each other. What does that mean, to subtract two equations? Don't worry about what exactly that means, but I'm just going to take the two equations and I'm going to subtract them. So I'm going to subtract all the x's, subtract all the y's, and subtract all the numerical quantities. Okay, so I'm going to take, I'm going to take all the x's and subtract them. So let's see what happens here. I got 2x, take away 2x. So that's going to be 0x. So it'll give me no x's anymore. 3 subtract -1. There's a hidden 1 here. Gives me +4, right? 3 take away -1 equals 4. And then 20 take away -4. That becomes, so 20 subtract -4 is 24. And this 0, that's nice because it's gone. So really, all I have is that 4 times y is 24. So the number that satisfies that is 6. Right, and I got that by, I can subdivide both sides by 4. And I end up with a value of 6. So right away, I managed to solve half of the problem. I've got y is 6. Then I can go in and replace it in the equation again. So 2x minus 6 is 4. -4, sorry. So that's going to be -6, and solving, I get that x is 1. So my final answer is going to be 1, 6, right? We write the x first and then the y. Hopefully you've seen these 3 dots before. That's therefore. Therefore, xy is 1, 6. Why don't we quickly, let's jump over to Desmos. So what was it? It was 2x plus 3y equals 20. And 2x minus y equals -4. Is that correct? Yes. And if we look, oh, our answer is 1, 6. So graphically, I can show that it's 1, 6. And using elimination, I can get 1, 6. So this is very nice when the numbers are matching up there. So you can just cancel them out by subtracting the two equations. And again, we can plug them in. We can take our numbers. We can take our two equations. We can replace x and y with 1 and 6 and work it out. So anytime it says verify the solution or check your answer, yeah, we're done. The left-hand side, oops. Apologies for my messy writing. It's hard to write on a screen. And the left-hand side equals right-hand side. And we're done. Now, what happens if we get a little bit more complex problem where if you look at these coefficients, none of them match? Right? The x is 4 and 3, so we can't subtract or add. 2 and 5, but nothing cancels out. So we have to find a way in which we can make them cancel. So we have to multiply the whole equations by whatever numbers we can so that we end up having numbers that can subtract. So I see 4 and 3 there. I know that the lowest common denominator of 4 and 3 is 12. So what I'm, well, not lowest common denominator, the greatest common factor, sorry. Is that right? I forget. I just want a 12 here. So to get a 12, let's call this equation 1. I'm going to multiply equation 1 times 3 because 4 times 3 is 12. And then I'm going to multiply equation 2 by 4 because 3 times 4 is 12. But that means I'm going to have to multiply everything times 4. So this one times 3, then it's going to be 2 times 3, not 2 times 2, Mr. Stone, and 14 times 3, 3x times 4, -5y times 4, and 22 times 4, which will end up working out to 12x plus So 4 times 3 is 12x, 2 times 3 is 6x, 14 times 3 is 42. 3 times 4 is 12, 5 times 4 is 20, and 22 times 4 is 88. Okay, so hopefully I'm not going too fast, but one of the really nice things about recording these videos is if I ever do go too fast, or if you miss something or you forget something, you can always just go back and check. So again, now notice that we have the x coefficient is 12. So I'm going to take the two equations again and subtract them. Now you could, if you had the same numbers but they had opposite signs, so let's say you had 12 and negative 12, you would add them together, right? Because if we add the same numbers with opposite signs, right, we end up with 0. But in this case, since they're the same sign, I'm going to subtract. So I end up with 12 minus 12, which is 0. 6 take away negative 20. So 6 subtract negative 20 is positive 26. And 42 subtract negative 88 is positive 130. So the x's are gone. We've eliminated. That's why it's called elimination, right? We've eliminated one of the numbers. Variables. So we've eliminated x, and we end up with 26y is 130. So y is 5. It's a weird one. 130 divided by 26 is 5. But yeah, it works. So we have half of our answer. We have y. Now we're going to take our number, our y, and replace it into one of the equations. Which equation? It really doesn't matter, right? Because I've taken both equations. I've used information from both equations to do my elimination. In substitution, we have to substitute it back into, well, really it doesn't matter actually. Use the easiest one. In this case, I had a choice of either multiplying by 2 or multiplying by negative 5. Multiplying by positive 2 is easier, so I just plugged it into that equation. It would be the exact same if you plugged it into equation 2. So 4x plus 10 is 14. Subtract 10 from both sides. We end up with 4x equals 4. Divide by 4. We end up with x equals 1. So our little therefore statement, xy equals 1, 5. Should we check this? Let's switch over to Desmos. 4 to 14. So it's 4 to 14. 3, negative 5, negative 22. 3, negative 5, negative 22. And when I check, oh, look at that. 1, 5. Magic. Okay, so please feel free to use Desmos to check if you got your answer right or not. So quick recap here. To solve linear systems, we have 3 different methods. We can use graphing, we can use substitution, or we can use elimination. All right. So now what I'd like you guys to do is to go through all the D2L notes. There's a bunch of examples. Try out all the examples. Please, I know it's tempting. I know it's tempting to go on to D2L and just I know it's tempting just to go on D2L and go straight to the bottom, straight to the assignment, and try to do the assignment because it's not very much work that way. But you don't learn very much. The point of doing math is to practice and practice and practice until we end up with, math skills that we're going to be able to use later in our math careers. So it's very important. It's vitally important that you practice the problems and not just answer the 4 problems in the assignment. This is the assignment you find at the bottom of lesson 1. And another thing, a very important thing, please, if you get a piece of paper and you do all your work, don't just take a picture. Don't just take like 6 pictures and dump them onto D2L. That's almost impossible for me to mark. Okay, figuring out the order in which they're in, finding out where they are, it basically adds half an hour for me to mark one simple assignment. So please use Adobe Scan, use Office Lens, take your stuff, scan it into there, make it one document, and then submit that one single document. Okay. eventually I'm just going to tell you, if you dump like 6 or 7 pictures for me, I'm not going to mark this. I can't. I physically, I just can't. There's, I have 35 kids in this class. It's a academic applied split. There's 35 kids. I cannot do that amount of work. Okay. So make sure that you have your, that's incredibly distracting. The sun is blowing out my green screen. Sorry about that. Another thing, you can do this all in equation editor on Word. Word has the ability to write your equations nicely. I didn't say that. Let's go back here for a second here. Notice when I do these problems, one of the things that I've done is I've always used my equal signs as my sort of justification, my stacking. Always stack on the equal signs. In mathematics, the equal signs basically are your lines that you use as your justification. Okay, it's not left justified, it's not right justified, it's equal sign justified. Okay, so make sure you and when you use a equation editor, there's ways you can align by characters. I'm going to post a I'm going to link. Sorry, I'll put in the link to in the description on this video. There is a link to one of my videos I did in a physics class on how to use equation editor. So if you want to do it not by paper is probably a lot faster for you. But if you want to do it digitally, you can use equation editor to make it nice. If you just put it in directly using Word, it's going to be a big mess and it's going to be hard to follow for yourself to follow. I could probably mark it, but it's going to be a bit of a mess. Equation editor makes things nice and pretty. Like all these equations in this PowerPoint, I did them all myself using equation editor. All right. So you can watch that video and figure it out yourself. So the homework here, download Adobe Scan or Office Lens first, okay? Then go do all the problems in lesson 1 and then do the assignment and then submit it into the Dropbox. All right? So I hope that goes well, and I'll be seeing you later.